What's up guys, my name is Nishit Tarantula. I know we're all meeting after a long time, so be ready because I'm gonna explain you about Michelson-Morley Experiment. Do you know, every wave requires a medium to travel. Suppose sound waves need medium to travel like air, sound. You can hear that sound traveling through the air. And there's no air in space, that's why astronauts are unable to hear what the other astronaut is saying in space because there's no air. But in space they use some technical gadgets to hear, and sound also needs another medium such as water. Sound can also travel through water and other solid materials like iron, wood, etc. So light is also a wave particle. Light is also a wave, wave energy. So it also needs a medium to travel, and that is an imaginary medium which is known as ether. E-T-H-E-R or A-E-T-H-E-R. Both are same, ether. You pronounce it ether, okay? So it's kind of imaginary path for light to travel. You can say that light travels via air, because in space there's no air, but still light from stars reaches the earth. So there should be any medium for light to travel, and that medium is known as ether. In 1887 there were two scientists, Albert A. Michelson and Edward W. Morley, who conducted an experiment in 1887 to find out ether. So let's see what they did. So in 1887, what both the scientists did, that they made such kind of setup which have one light source, a half reflective mirror. What this mirror does is that the light which comes from the light source, it divides the light into two, which travels at this part and half of the light travels there. So this is known as a half reflective mirror, and there's mirror 1 and there's mirror 2, and here is a detector. Okay, so what they did, that when we switch on the light source, there's a light wave which travels to the half reflective mirrors. Hope it's visible. The light source releases some light waves which reaches the half reflective mirror. The half reflective mirror divides the light into two, and half of the light wave reaches the mirror 1 and the other half of the light wave reaches the mirror 2. You need to remember that the distance from the half reflective mirror to the mirror 1 is equals to the distance between the half reflective mirror to the mirror 2. Both the distance are same. Let it be wave X and let it be wave Y. Okay? After that, what happens, that both the mirror reflects back their waves to the half reflective mirror. The waves are reflected back, and same the mirror 2 does, it reflects back the light wave to the half reflective mirror. And then this mirror transfers both the waves to the detector. This wave is the wave X and Y. That this light travels to the half reflective mirror, comes to the mirror 1, and the half comes to the mirror 2. And they are reflected back to the half reflective mirror, and it gets transferred to the detector.
Oh, strangers in the nighttime, there's never a right time to say hello. Yeah.
So if there's an ether wind which travels in any direction, suppose this direction, if the ether wind is traveling in this direction, suppose, so so a light should travel through the ether. So what will happen is that this light will reach to the mirror 1 faster as compared to before, or as compared to mirror 2. Okay, this light will move faster to the mirror 1, and the light which gets reflected to the mirror 2, it is slightly bent in this direction and touches the mirror 1, okay, when the ether wind is flowing in this direction. But when mirror 1 reflects back the light, it should be pretty slower as compared to before, and when mirror 2 will reflect back the light, they should be in the same direction to the half reflective mirror, and then the half reflective mirror will reflect it back to the detector, but the ether wind is flowing in this direction. This X and Y wave will be pretty slower and reach pretty and will reach at pretty less time as compared to before to the detector. So what they thought is that if there's an ether wind, there will be a difference in time taken by the light beam to reach to the detector. Light is a wave. Light is a wave, okay? A wave consists of a peak and a trough. TROUGH, trough. When we add both the waves of light, we get another wave with more higher peaks and more lower trough as compared to these. So this is our light, and this is the half reflected light X, and this is the half reflected light Y. This is known as constructive interference. So they just thought that if there's an ether wind, there will be a difference in light to reach to the detector, but they tried this experiment for very long, but there was no such change in the speed of light, and therefore it's concluded that ether doesn't exist, or light doesn't need a medium to travel. Thank you guys, that was the Michelson-Morley experiment. Very long ago I told you that I'm working on something very special. Let's see. Versus what? Wait a minute. Wait for a while. There were some of the paperworks which I did for that. So keep on supporting me and subscribe to my channel, and don't forget to share my channel. Thank you, bye.